Okay, hello. This is for everyone. So algebra 4. So most of us got here, I think sixth period we ran out of time. I don't know how or why. But ideally everyone was sort of set up with this last one, and so I want to just go over it real quickly. So this one is tough. It's not easy. And the idea is that you know the roots and you have an imaginary situation. And so working backwards, you could write the equation in standard form. So this is standard form right here. This is standard form. Yeah. This is like one thing in math where sometimes it's like not so bad to work backwards. The more complicated stuff we start to see, then it becomes kind of a pain. So take some ibuprofen, everyone. All right, so we have our roots, and so I use this as an example. So this is like a real number example, just to sort of like set us up. So if we have roots, right, we can set this factored portion up, and then we can multiply out. And so here are my, let's look at the purple. So here's what I have. So I'm going to multiply now. One thing that we like to show y'all is the area model. Oops, that's a T. Especially if I have like multiple, if I have like 3, then it's kind of nice to do the area model. Just so you don't lose anything. Okay, x times x, x squared, negative 2 times x, negative 2. This is negative xi. Great. Let's do a different color for this row. Negative 2x, this positive 4. This is positive 2i. X times I is xi. Negative 2i. Negative I squared. But remember that I squared equals the square root of negative 1. I equals... Wait, no, sorry. Oh my gosh. Ooh, backwards. I squared equals negative 1. Okay, oof, that was close. That was close. Facts. Okay, so then let's do some combining like terms. Everyone loves like terms. Here are my x's. Here are, I have negative xi and positive xi, so those actually cancel out. And then I have I have plus 2i and negative 2i, so those also cancel out. And then I just have this. So let's rewrite this. Let's use blue. So I have x squared, right? So I have this. That box is good. And then I have these two combined, so that is negative 4x. Those are gone, those are gone, those are gone, those are gone. So I have plus 4 minus I squared. And you're like, wow, great. It was so close. It was so good to be like so close to being perfect. So here's what I'm going to do. I'm going to use this fact. So I'm going to say, okay, sweet, right? I've got this, right? This is Cardano's whole shtick here. Negative 1 because I squared is negative 1, so I'm going to sub that in. Minus 4x plus 4 just to show that this is plus 1. X squared minus 4x plus 5. Boom. Yes. Love it. So here is where if I think about my... How's my camel look? If I think about my camel... Oh dear. What did he do to deserve this? You get the idea. So here was my I squared. But really, that is a real... Oh, really? It's a real number, right? So then it like comes back over here and I get a real number. So that's what I'm talking about when I say like we move from real to imaginary, right? Like I can move back and forth between these two things. I'm not limited in like the ability to go from the imaginary to the real part. So this is the answer. Okay. And the solution, remember, so like that's for the record. I don't know. Mince, qu'est-ce que je fais? Qu'est-ce que je fais? Je fais une petite erreur. Here's my camel. Here's my little diagram. Well, you know what? Let's put this over here. It doesn't really matter, does it? So if I think about this, so my solutions, right, were x equals 2 minus I, x equals 2 plus I for this quadratic. Great. Love it. Next. Okay, so this is page 7. Oops. Ooh. Page 7, page 7, page 7. The polynomial function. Okay, so this is cubic. So this, I don't know why I love this. And I'm so sorry. So this is cubic because it's x cubed. Yeah? So the leading coefficient. It tells us one of the zeros. It tells us that. So what this means, let me find my key really quick to see how I set it up. Oh, I didn't really do a good job. So what this means is that one of our roots is x plus 1. So that's one solution. So again, I have something like this. Let's say this is minus 1. I don't remember because I'm going to have imaginary things. So then I have some sort of function that crosses here. And maybe it goes up and down. But I have one real root. Okay, so what we want, and I don't know why I would have left this here without talking about polynomial long division. So I'm sorry I did not, I think maybe, or I gave it, I don't remember what I did last year. Who knows? So one thing we can do, and we're going to talk about this in our next unit, just like a smidge. I just need 3. I know, just hear me out. So this is like x plus 1. So again, thinking about an area model. And so if I know that I'm trying to like factor, right? So x cubed. So I'm going to need something up here that's x squared. Because x squared times, right, like this times this is this. X squared times x is x3. So then if I force that top, let's say this is x squared, because x squared times 1, right, times 1, oops, times 1 is x squared. Okay, so then what I need to have happen is I need whatever is going to like live in here, I need that to equal 4, you know. So then that must be 3x squared, because x squared plus 3x squared gives me my 4x squared. So I'm like forcing one side and finding the other. This is called polynomial long division, and I'm so sorry. So then for that to be true, right, remember that I have my x here. So I need x times 3x squared. So then I have to have a 3 and an x up here. 3x times x equals 3x squared. So I have to force one side. I know. So then let's do purple. So then I have 3x here. Because 3x times 1, right, equals 3x. Okay, so what I need though, let's grab another color. I need 11x. I have 3x already. So I need to like finish combining two numbers to get 11. So 3 plus 8 is how I'm going to do that. So this must be 8x, because 3x plus 8x is 11x, and that's what I had here. Yeah, I know. So then for that to be true, right, like it has to be sensical in some land, this must be 8. 8 times x is 8x, that's what I have here. 8 times 1 is 8. Yeah, because then these, remember, these are, ooh, I need a highlighter. These are the things that combine for the 8. Okay, so then, let's grab another color. Let's grab aqua. So then this is the other parts. So I have p of x. I know, you're like, we didn't ask for this. Here's the solution I was given. Here's my quadratic portion that I can now use the quadratic formula for. I know. I'm sorry. So then I'm going to use the quadratic formula for this part only. If you want to look up the cubic formula, you can do that. I would not stop you. Okay, so from there, right, I have A is 1, B is 3, C is 8. So I'm going to have x equals the opposite of 3 plus or minus. 3 squared is 9, so I'm just going to write that. Thank you. 4ac, 4 times 8. I'll write that. All over 2a, which is 2. Plus or minus. 9 minus 32. Where's my calculator? 9 minus 32 is negative 23. So, oops. So from here, it's negative underneath my square root. My discriminant is negative, so I must have imaginary solutions. And that should make sense because I might be like up here somewhere floating. So then I would have two solutions. Let's check out what the calculator says. 3 plus square root of negative 23, parenthesis, negative 2, or divided by 2. It's always 1 point. It's like always a 0.5. Negative 1.5 plus 2.39. I'll stop there. It should be... Oh, it didn't show me my I. But I found it. I just had to push the arrow button. Minus 2.39. Oh, it's 2.4, but this works too. Okay, so you have three solutions. So you have x equals negative 1, x equals negative 1.5 plus 2.39i, x equals negative 1.5 minus 2.39i, 2.4. But three solutions because it's a cubic. I know, it's so much fun. This is, I'm sorry, here, sorry. I don't know why I did that. I apologize. It's been a rough year. Okay, so let's look at the next thing. How can you use the quadratic formula to determine whether or not a quadratic function has complex roots? So you are going to look at the radical. Look at the radical. That's what that's called. So this number is called the discriminant. Discriminant. I'm going to post a PDF with notes. And so there are definitely, like, there's a lot of information to be had. So I don't want to overwhelm you right now. But if it's negative, it has no real solution. If it is positive, like it's greater than 0, it has two unique solutions, x-intercepts. If it equals 0, it has one because it like bounces on the axes. I know, I'm sorry. Okay, part B. How can you use the complex root of a parabola or quadratic to write a function in standard form? Okay, so this, it's kind of tricky to set up, but really like the bare bones of it is that you, the mathematician, can multiply. Oops. Multiply. Then, oops, sorry. Can't read my own handwriting. Sorry. You can multiply them, not then, just like a binomial. Binomial. So like x plus 2, x plus 3. Right? Just like that. You can multiply them. So multiplication is like the name of the game here. All right. If the nth degree polynomial has two real roots, okay, how many complex roots must it have? Oh my gosh. I'm not doing a good job today. So what this means is that like there's at least like one real root right? Like, and the rest can be a mixture. So that's sort of like part D. So what this is asking is like, if it's the nth degree and you have, like, let's say you have some real and then some complex. So you have like a mixture of like real and then complex or imaginary complex. So that would be like I. So then, what does it say? It has 2 real. So then it would just have to have, if an nth degree polynomial has 2 real roots, how many complex roots must it have? It has to have like at least 1. This question doesn't make sense now that I'm thinking about it out loud. If it has 3 real roots, nth degree, because if it's a second degree and it has 2 roots, then it would have 0. If it has 3 real roots, how much? 3 real roots, 2 real, 1 complex. This question doesn't make any sense. I don't remember what this question is asking. It has to have, like, generally, oh, fudge. I'm thinking. I'm looking at my notes from last year. So if it's odd, it has to have 1 real root, and then the rest can be complex. If it's even, you can have all complex, like it could be a floating parabola. And so I don't necessarily need a real root. And so I think this is supposed to be about odd functions. So here, let's write a note about that. I'm sorry. So if it's even, you can have all complex roots. So think about that, like a floating parabola. Right? So I can be up here. We've seen that. If it's odd, so that's like x squared, x to the 4th, x to the 6th, etc. Right? I can have floating stuff. If it's an odd function, meaning that it's like a cubic or something like that. So let's do this. Odd. So you have to have at least 1 real root. The rest can be complex. Ooh, can be complex. So for example, like we saw just in our equation that we did up above, right? I can even have like, I can go up here and have like a bunch of bumps. Woo! But I have to usually cross at least once because of domain and range. So I have to have at least 1 real root, and that's because I'm breaking the x-axis. Sorry, I'm not sure. It has to have at least 1 real root if it's odd. And I'm not sure what that question was really asking now that I'm sitting here with you. Or not with you, but sorry about that. Okay, so on page 8, I don't have a picture of that now that I'm thinking. So let me just write it real quick. Let's go plus. And that is the wrong one because why would I have the real one? We did our camel. Okay, so page 8 is extra practice. So let me just do that. Is extra practice. Find all the roots, real and complex, of each polynomial. Okay, so we can factor some of these, I believe. That one I can, that one I need quadratic formula. Okay, so the first part, and I'm trying to think about, I have this here. Okay, so A, B, and C. So first let me write it out. We have f of x equals x squared plus x plus 11. So this is a, b, c. So my quadratic formula, opposite of b, plus or minus b squared, which is 1, minus 4 times 1 times c. So I'm just going to plug in c because it's times 1, all over 2a, which is 2. Okay, so then let's simplify plus or minus. What is that? Negative 44, so negative 43. So that's negative, so I'm going to have imaginary, and I always drop that 1 right there. I don't know why. All right, in my calculatrice, that's how you say calculator, negative 1 plus square root negative 43, parenthesis, parenthesis, divided by 2. So I have negative 0.5 plus 3 point, here let's round correctly for once, which means I have the same thing, but then the conjugate. Okay. Great. Love it. Fantastic. Yeah? Let's look at part 2. Okay, and then the other thing it wants you to say, or no, it doesn't, but these are just both, so like 2 complex roots, just for the record. Okay, part 2, we have g of x equals x squared minus 4 times x squared, move that over, x squared plus x plus 2. So I'm going to do quadratic formula for the second part, but for this first one, this is a difference of squares. Difference of squares. So I know because of that, it's like this, x minus 2, x plus 2, which means my solutions are x plus or minus equals plus or minus 2. So this is 2 real roots, just for the record. Here, I'm going to do quadratic formula. Yeah, because I can't factor that. So a equals 1, b equals 1, c equals 2. So x equals the opposite of 1, plus or minus. 1 squared is 1, minus 4ac, which is 4 times 2, because a is 1, all over 2a, which is 2, because 2 times 1 is 2. So let's simplify this, plus or minus. What is that, 7? Hold on, let me fix that. Let me fix that. All over 2. Okay, in my calculator. Negative 1 plus square root of negative 7, parenthesis, parenthesis, divided by 2. A lot of 1/2. Negative 0.5 plus 1.3i, which means I have the conjugate, which is minus 1.3i. So I have 2 complex roots. And I have 2, let's write this again, 2 real roots. So here I have 4 total because it's a 4th degree. See how that works? It's brilliant. Okay, let's see. There's a lot on page 8. There's a lot on page 8. There's a lot on page 8. Okay, well, let's just pure vita this here. Part 3. This one is, I have to do quadratic formula twice. So just heads up on that. H of x equals x squared minus 2x minus 8. And I don't think minus 4 plus 2. Actually, that one I could factor. Well, I just did. So you don't need to do quadratic formula, but here, I guess I'll show it. So this, any quadratic formula, A equals 1, B equals 0, C equals 9. Here, this one you could factor. Right? Yeah. If you do the quadratic formula, that's also fine. So then that would be x equals 4, x equals -2. But for me, factoring is faster. I did, when I did my notes for last year, I did the quadratic formula. And you get the same answer. But for me, that just takes a little bit longer. All right, so these are 2 real, by the way. 2 real roots. Okay, so here we're going to do this. X equals the opposite of B. Opposite of B, which is that. I'll just write it. Plus or minus 0 squared minus 4ac. Okay, all over 2a. So here I'll just do everything. 0. So I'm just going to have plus or minus. And then I'm going to have negative 36 divided by 2. So this is the same thing as, right, remember we talked about breaking this up over 2. So negative 1 under the square root, and that would be 6 because square root of, well, here, no, I'll write that. And then I'll show you on the next step. 36 over 2, everything. Let me zoom out and enhance. Well, I'll just move that up. So, plus or minus 6i divided by 2. So that is 3i and minus 3i. So x equals x equals. So then I have 2 complex roots. So sometimes you don't need a calculator. The 36 is the 6. The -1 is the I. Okay. So for this one, same thing. You have 4 roots total. So you have 2 real. And then you have 2 imaginary. Four roots total. Because it's 4th degree. Solve each equation below, find that. Why did I do that to you? Okay, well, we've made it this far. This is 1. It looks like this, -5x squared, 3x plus 10. So I'm going to say this, because if I add it to both sides, plus 3x plus 10, quadratic formula A, B, C. X equals the opposite of that, plus or minus. 3 squared is 9, minus 4. A is 5, C is 10, oh dear. All over 2a, which is 10. Okay, so let's simplify. X equals -3 plus or minus 20, 200, 9 minus 200, I think. Let me triple check that. 20 times, okay, so 9 minus 200. So that's going to be complex roots because I'm going to have a negative underneath my radical. It's -191 all over 10. Put it in your calculator. Plus square roots, -191, parenthesis, parenthesis, divided by 10. Okay, so x equals -0.3 plus 1.38i, which means that my conjugate is this. Okay. So this is 2 complex roots, solve each equation, find real roots complex. Okay, so that's that. The next one, let's do a new page because this one looks kind of messy. Okay, so part 2. So this is number 6, part 2. I have 1, 2, 3. I have 5. My degree is 5 because I have x squared here. I think I need the quadratic formula for that. This x minus 4 squared is nice because I don't need to do that, and this is linear. Like it doesn't have a power, so I can solve that. So let's break that up. So this needs the quadratic formula. This x equals 4. This x equals negative 1/2. Because 2x plus 1 equals 0, minus 1 minus 1, 2x equals negative 1, divided by 2. No. Yeah? Okay. So all we really need to worry about then is this part, this quadratic formula. The one thing I do want to say is like, here's my leading degree, here's a degree, and then this is a degree of 1. So I have like a 5th degree polynomial. We're going to talk about polynomials next, so just hang tight. Quadratic formula. A, B, C, so opposite of B, plus or minus b squared, which is 9, minus 4a is 1, c is 5. If you do this enough times, you can just really be a quadratic formula wizard. 9 take away 20 is a number that I know, and I'm not afraid to admit that I just used my calculator for that. It's been a day. Okay, so I'm going to have an imaginary number because of my negative underneath my radical. Oh, I'm going to plug this into my calculator, who is my best friend these days. Not joking. Divided by 2. X equals negative 1.5 plus 1.66i, which means I have the other part. Oops. Negative 1.66i. So here are my two complex roots. Oops. And then I have a double root. So then I have x equals 4, x equals negative 1/2. So these are real roots. And then this is a double. So it's going to have like a bounce. And again, we're going to talk about that next time. So there's 5 roots total. 5 roots total. Smiley face. There's one more. Who even made this? Why did I do this to you? I'm so sorry, everyone. Okay. Quadratic formula plus. That's not a difference of squares because it's plus. This is a difference of squares. And this is not. Okay. So this is a difference of squares, which means it's x minus 1, x plus 1. So then I'm going to have x equals plus or minus 1. That is an x, and I know it has like a weird thing. So let me redo that. Okay, and then these are going to be quadratic formula. So let's do that here, Q, F. B is 0, so opposite of 0, plus or minus 0 squared minus 4ac all over 2a, which is 1. So plus or minus, I'm going to get negative 100 all over 2. So notice that when b is 0, I have like some nice stuff happening here in my life. So this is going to be 10i. And see that other example that I did with like the 36? So this is plus or minus 5i, which should make some sense, right? I have this 25 here, right? Like that should make some sense that I'm getting 5i for my imaginary. So probably it's true, right? Let's make a little hypothesis. Then this should be plus or minus 3i, right? If I have this plus 9. Just some pattern, just some like patterning. But let's prove it because I've been wrong before. Opposite of b, which is 0, plus or minus 0 squared minus 4a, which is that, c, which is 9, all over 2a, which is 1, x equals plus or minus, comment je peux faire, negative 36, we saw that before, 2. So then I get plus or minus 6i over 2, which is this. Sick. Okay, so bring this cutie down. X equals plus or minus 1. So I have 6 roots total. I have 2 real. And then I have 4 fake, 4 complex. Yeah? And then my degree, so let's think about this just for a hot second. I have a second degree, second degree, second degree. So that's why I have 6 total. I have a 6th degree polynomial. So this is 6th degree. I know. Okay, I'm going to stop there because I want to do the rest with y'all. But yeah, that's that. Okay, bye.